Hey guys, Miss Fearing here. Welcome to Unit 9, Notes 2. Today we're going to go ahead and we are going to review our power properties as well as factoring. So we looked at both of these things back in Unit 3 and 4, and we're going to use them a lot for the rest of Unit 9. So we're going to spend a day just kind of reviewing what we talked about a while ago. So we've seen these before. These are our power properties. So let's go ahead and review those a little bit. When we have a product of a power, or when you are multiplying powers, we add the exponents. So if I'm looking at a to the 6 times a to the third, I do 6 plus 3, so a to the 6 plus 3, which is going to give me a to the 9th. So when we multiply, we add. Now, when you have a power of a power, we multiply the exponents. And actually, I do this a little differently, so we're going to kind of ignore this multiplying exponents. When you see this little 2 on the outside of the parentheses, that means whatever's in the parentheses, I have 2 of them. So I have 6a to the 6th times 6a to the 6th. Now it turns into a multiplication problem, which then brings me back up to the adding the exponents. So I know that I'm going to have a to the 6th plus a to the 6th, so I'm going to get a to the 12th. The one thing you have to remember is that when you are multiplying, we only add the exponents. We multiply the coefficients, or the big numbers in front. So I'm doing 6 times 6, which is going to give me 36, a to the 12th power. Remember, our 0 power tells us that if I have anything to the 0 power, it is going to equal 1, no matter what it is. So this whole thing is to the 0 power, which means this whole thing just equals 1, and I'm done. And then when you are dividing, remember quotient tells me to divide. When I divide, I subtract the exponents. And Miss Fearing does it the larger number minus the smaller one, and it goes where the larger power was. So I'm going to do a to the 6 minus 2, which is 4. And the 6 was the larger one, so those 4 of them are back up on top. You can write it as a to the 4th over 1, or just a to the 4th. So let's go ahead and look at some examples here. Example number 1, I have 4x times x squared times y to the 3rd. So since they're next to each other like this, I am multiplying those things. So I'm going to put all of my variables together that are the same. So I need my x's together. So I have a 4. I don't have any other coefficients, so that's just going to stay 4. X times x to the 2, or x squared. Remember, if there is no power there, it's an imaginary 1. And when I multiply, I add them. So I end up with x to the 3rd. And then the y to the 3rd is all alone. There's nothing else there, so it's y to the 3rd. I only have one of each variable, so I know I'm done. Number 2, I have 4xyz to the 3rd, all to the 0 power. Remember, anything to the 0 power is 1, and we're done. Example number 3 here then. I have 6y, x to the 3rd, y to the 4th, x, all squared. So in a problem like this, I want to look inside the parentheses first. So I'm going to look inside here and see if I can simplify anything in there. So those are all multiplying, so I know that when I multiply, I can add the powers. So this y here is an imaginary 1, and this x here has an imaginary 1. So I'm going to put my x's together and my y's together. So I still have a 6. I have x to the 4th because I have a 3 and a 1, and then y to the 5th because I have a 1 and a 4. Now I still have all of this squared. So I like to say, well, if I have that squared, that means I have 2 of those things. So I have 6x to the 4th, y to the 5th, times 6x to the 4th, y to the 5th. Now I'm multiplying again. So when I multiply, I add the powers, and I multiply the coefficients. So 6 times 6 gives me 36. X to the 4th times x to the 4th, I add them. So 4 plus 4 gives me 8. Y to the 5th times y to the 5th, again I add, so I get y to the 10th. I only have one x and one y in that equation, or in that expression, so I am done. I want you to pause the video and go ahead and try number 4 now. So for number 4, we were multiplying. Remember, you multiply the coefficients, so I did 4 times negative 7, got negative 28, and then you add the powers. Don't forget that any variable that's there without a power has an imaginary 1 with it. If you got that one wrong, come check with me before moving on. Example number 4 here. So I have 4AB divided by A. So I know that when we divide, I want to subtract the powers. So I have a to the 1 divided by a to the 1. So I'm doing 1 minus 1, which is 0. So all I'm actually left with is the 4b that's on top. So you could write 4b over 1 or just 4b. Example number 6 then. We have 16x to the 5th y to the 7th divided by 4x to the 6th y to the 4th. We again are dividing, so we are going to divide the coefficients. So 16 divided by 4 is 4, and the bigger number's on top, so that's going to be on top. Now, I have x to the 5th divided by x to the 6th. Remember, we want to do the bigger number minus the smaller one and put it where the bigger power was. So I'm going to do 6 minus 5, which is 1, and that was on the bottom, so I have x to the 1 on the bottom. Same thing with my y's now. I have y to the 7th divided by y to the 4th. So I'm going to do the bigger one minus the smaller one and put it where the bigger power was. So y to the 7th, I'm going to do 7 minus 4, which is going to give me 3, and the bigger number was the 7 on top, so the 3 is going to be on top. So now we're going to switch gears a little bit, and we are going to come back and remember factoring expressions. So our first step when we factor is always to try to factor out a GCF. If there is no GCF, or after we do that, then we go to set up the x. Remember, when you're looking at your x, you have a times c on top, and b goes on bottom. Step 3 then is to solve the x. So find the two numbers that multiply to top and add to bottom. So again, we multiply to top and we add to the bottom. And then we can factor by grouping. Very important note, if a value is 1, the numbers on the x are the factors. So this is going to be our fast way of using this when a is 1, and we really want to get used to that because there's a lot of factoring coming up in the rest of this unit. So let's look at example number 1 here. First things first, is there a GCF I can take out? Do they all have something in common that I can take out? Well, they do not. So now I'm going to go ahead and I'm going to set up my x. So I know that I'm doing my a, 1 times my c, 5 to get the top. B goes on bottom, so 6 is on the bottom. So I'm looking for two numbers that multiply to 5 and add to 6. So that's going to give me 5 and 1. So now, since my a value is 1, that remember right there is a 1 next to the x squared, I can get my factors from these two numbers right here. So my first factor is going to be x plus 5, and my second factor is going to be x plus 1. I don't have to factor by grouping then, and I'm just done. So number 2 then, again, go through your steps. Do they both have something in common that we can take out right away? Do they have a GCF? Well, in this situation, they do. They have a GCF. They both have a 3 in common, and they both have an x in common. So I'm going to take a 3x and put that out front, which means I need to divide each thing by 3x and see what's left. So 3x squared divided by 3x is going to leave me with an x, minus 15x divided by 3x is going to give me a 5. There are no more x squared, so I know I'm done. There's no further I can go. Let's look at number 3 here. First thing first, is there a GCF? There is no GCF in this problem, so we're going to set up our x. So we're going to multiply a times c, so 6 goes on top, and then b goes on bottom, so 7's on the bottom. So two numbers that multiply to 6 and add to 7, I have 6 and 1. Now, that a value is not a 1, so we can't get our factors right away, so we have to factor by grouping. So to factor by grouping, we are just rewriting the 7x here as these two instead, so that we have 4 terms instead of 3 terms. So I still have a 3x squared plus 6x plus 1x plus 2 as my constant. So now I can factor by grouping. So GCF of my first one, they both have an x in common and they both have a 3 in common. So I'm going to take a 3x out of these. When I do that, I'm going to be left with x plus 2. 1x plus 2, GCF there is a 1. Some people say, well, they don't have anything in common, so I'm not going to take anything out. But you always have to take something out. So I have a plus 1. When I divide that out, I get x plus 2. The parentheses are the same, which is good. We want that, so that's my first factor. And then the GCFs that you took out, remember, are your second factor. Example number 4 then, I have x squared minus 49. If you don't remember that this is a special case, you can always go through and say, do they have a GCF? No, well then we can factor by using our x method, so I get negative 49 on top. There is no middle term, so it would be 0. So then I would get 7 and negative 7. And those two, because my a is 1, would be my factors. So x plus 7, x minus 7. If you remember your special cases right away, we know that when you have two terms, if you can take the square root of this, then we have that number here and here. And then since there's only two terms, I have a plus and a minus. But that's bringing you back, so don't forget, you can always use your x method to solve. You never have to remember the special cases. So I want you to try numbers 5 and 6 on your own. Pause the video, do the problems, and then come back and check your answers. So here are the two answers I got. For number 5, I got x minus 5 and x plus 7. Because that a value right there is a 1, I can get my two factors from my x right away, and I don't have to go through factor by grouping. For number 6, that a value was not a 1, so I had to go by factor by grouping. So I had to rewrite the middle term as these two factors and then take out GCFs from both to get my two parentheses at the bottom, my two factors at the end. If you have any questions on this, please come chat with me before moving on to the assignment for the day.